I did not go for lunch. This will not surprise anyone who knows me. When I find something wrong in a dataset, I become unreasonable about it. My former supervisor at the Université called it a professional defect. I prefer to think of it as thoroughness, which is the same thing described more generously. The fine structure constant had shifted at 03:14 a.m. I had the evidence in front of me. The question was whether it was mine alone, a problem with my instrument chain or my reduction pipeline that I had somehow missed, or whether it was real. I started checking other sources. The Canadian Hydrogen Intensity Mapping Experiment at the Dominion Radio Astrophysical Observatory in Penticton runs continuous sky surveys.
Their data is publicly accessible within a 24-hour delay. I pulled their overnight files, ran my own reduction on them, and had a result in 11 minutes. Their hydrogen lines showed the same shift. I checked the Green Bank Telescope Archive in West Virginia. Same shift. The Parkes Observatory in New South Wales, whose overnight data was already 12 hours old by the time I accessed it. Same shift. 4 independent instruments on 3 continents, all showing the same fractional displacement of the 21-centimeter emission line, all starting at the same moment, all agreeing to a precision that ruled out coincidence the way a wall rules out walking through it. The fine structure constant had changed, globally.
At 3:13 a.m. this morning, I sat back and looked at the 4 plots on my screen, aligned so their x-axes matched. They were identical. The same line in the same wrong position, drawn 4 times by 4 different instruments that had no reason to agree, unless they were all measuring the same real thing. I thought, this is not my instrument. Then I thought, this is not anything I have a framework for. My phone buzzed on the desk. Elliot, did you take the parking permit out of the car? I can't find it. I looked at this message for a moment. Outside, a cloud moved across the narrow strip of sky visible from my office window, and the 40 minutes of northeast light I had arranged my desk to catch went gray. I typed, "Check the glove compartment." Sent it. Put the phone face down on the desk. This is not a complaint. I want to be precise about that. I turned back to the 4 plots and started thinking about who else might have noticed this and what framework they might have used to explain it. The literature search took longer than the data analysis. I was not sure what I was looking for, which makes searching difficult. I tried several combinations of terms: fine structure constant variability, spontaneous quantum decoherence, large-scale coherence collapse. Most of what came back was theoretical particle physics from the 1980s, which was not useful, and a handful of recent papers on quantum computing stability, which were also not useful. Then I tried directed quantum timeline convergence, which was a term I had invented on the spot because I did not have a better one, and which I expected to return nothing. It returned one result. Directed quantum timeline convergence, a theoretical framework for boundary collapse induction, published in Physical Review Letters 18 months ago. Author, Dr. Elise Moreau, Department of Physique, University of Sherbrooke. I read the abstract. Then, I read the full paper. It took me 41 minutes, partly because the mathematics was dense, and partly because I kept stopping to check whether I was reading what I thought I was reading. Dr. Moreau had constructed a complete theoretical framework for deliberately collapsing the quantum boundary between adjacent parallel timelines. The paper was framed as a thought experiment, the kind of speculative theoretical exercise that Physical Review Letters occasionally publishes when the mathematics is rigorous enough to justify the speculation. The premise? If the fine structure constant is a local property of spacetime rather than a universal one, it should be possible, given sufficient energy and the right resonant conditions, to induce a boundary collapse between two adjacent quantum branches, causing one to merge into the other. She had also included a section on observational signatures. What it would look like from the outside if someone actually did this. I pulled up my 4 observatory plots and placed them next to the paper's predicted signature diagram. I have been a scientist long enough to know what it feels like when data matches a prediction. It has a specific quality, like a key turning in a lock. A small, precise click of recognition that is different from everything else. The click was very loud. I looked up Dr. Elise Moreau. Her institutional page at Sherbrooke was standard. A professional photograph, a list of research interests, recent publications. She had a calm face. The kind of face that suggests a person who has decided something and made peace with the decision, which I have learned to find more unsettling than anger. I searched for her recent public appearances. Conference presentations, panel discussions, anything in the last year. The most recent result was a conference in Vancouver, 4 months ago. A 2-day symposium on quantum decoherence in shielded environments. Dr. Moreau had presented on the second day. I scrolled to the full panel listing. 3 other participants. 2 names I did not recognize. One I did. Dr. Elliot Vance, Deep Ice Decoherence Project, Creighton Mine, Sudbury, Ontario. I read this twice, then a 3rd time, which did not change what it said. Elliot had been at a conference with Dr. Moreau 4 months ago. A conference specifically about quantum decoherence in shielded environments, which was Dr. Moreau's area and also his. He had never mentioned it. He had never mentioned her name. He had never mentioned knowing anyone working on timeline convergence theory, which, given what I was currently looking at on my screen, seemed like something worth mentioning. I went back to Dr. Moreau's paper. I had not read the acknowledgements section. Acknowledgements are the part of a paper most people skip. A brief paragraph thanking colleagues and funding bodies that is professionally obligatory and personally revealing in equal measure. I read it now. She thanked 4 colleagues for their feedback on early drafts, 2 names I did not know, a funding body, and then third on the list, 3 words that sat on the page with the particular weight of something that has been waiting quietly for you to find it. Dr. Elliot Vance. Elliot had read this paper before it was published. He had provided feedback. He had known about this research, about the complete theoretical framework for deliberately collapsing the boundaries between timelines 18 months ago. We had still been together 18 months ago. He had never said a word. I closed my laptop. Outside, the cloud had passed, and the 40 minutes of northeast light had come back, falling across my desk in the specific way I had arranged everything to catch it. I sat in it and thought about the orange mug, the book I had not bought, the text about the parking permit, the way he said morning without looking up. I thought about a paper I had just read that described with precise mathematical detail how to collapse one version of reality into another. And I thought about how it felt to live in a life that fit perfectly and felt like someone else's suit. No, I thought. No.